This video demonstrates how an automatic image detection process works, presenting in an integrated way the stages of annotation, training, inference, and geospatial visualization. As a practical example, it focuses on the road infrastructure domain, specifically on the detection of guardrails and their respective damages, using the applications and tools adopted by Bluecover Technologies. The process begins with the image acquisition phase and is immediately followed by the annotation stage. At this point, the classes are defined, such as guardrails, damaged guardrails, wildlife reflectors, hectometric signs, viaducts, and traffic signs, ensuring consistency in data labeling. Whenever new scenarios or examples of damage are identified, additional images are added to the dataset. This continuous update improves the robustness of the model. Once the annotated dataset is consolidated, the workflow moves on to the training phase. The annotation process is carried out in Vannotate. First, an image is loaded into the platform. The object can be selected using a simple rectangular bounding box, which allows for quick and efficient labeling. For more precise annotations, a polygon tool can be used, enabling the user to manually trace the exact contour of the object. An adjustment tool is also available, allowing fine corrections to better align the annotation with the object's shape. Once the object is selected, the corresponding class is assigned, such as traffic cone or damaged guardrail. If necessary, annotations can be edited, removed, or the image itself can be deleted from the dataset. The training and testing process takes place in Vision Surveyor. First, a model template is selected, such as YOLO11N or YOLO11S, depending on the desired balance between speed and accuracy. A version name is then defined to clearly identify the experiment. The project ID from Vannotate is specified, which is available in the platform's URL, ensuring that the correct annotated dataset is linked to the training request. Additional parameters can be configured, such as class filtering by minimum number of annotations, which helps ensure that only sufficiently represented classes are included. The number of images reserved for validation or testing is also defined, allowing proper performance evaluation. Finally, the number of training epochs is set, and the training request is submitted. The training process is developed with Python scripts. These scripts can be divided into several code sections: install libraries, dependencies, export vAnnotate data, train the model, export results to Vision Surveyor. The train the model section may take some time. Be patient. At the end of processing, the trained model will be available with the precision results. This model will be the starting point for making automatic inferences on new images recordings. This is when the model's performance is validated under real-world conditions. Shifting now to VMap, the first thing that appears on the screen is the possibility to visualize the route taken through the map, where we can click and view the photos and detections generated. After that, we can analyze the camera roll of the road, considering all types of photos, or filter to see only the detections found. Within this option, we can further filter the detections by the class type we are interested in analyzing. We can also view the image data, such as the location coordinates, the exact time of detection, and its identification number. Finally, there are statistics available to help get a sense of how many elements were trained and detected per class. This solution reflects Bluecover Technologies' commitment to innovation in intelligent infrastructure monitoring. Discover more of our projects and how we transform data into actionable insights.